Hello, welcome back to NMI. In this video I'm gonna show you my Kaypro II. It's a luggable CPM machine based on the Z80. Super cool, but there is a small problem. When I got it a few weeks ago, it was not working. So in this video I'm gonna first have to fix it, and then we're gonna see how it works and some of its software. So let's go. So here we have my latest acquisition, Kaypro computer. I just got it about 2 days ago. I love it because it came with this nice bag and manuals, lots of cool manuals. I'll have to check if they are all scanned and available on the archive. If they're not, I will try to scan them when I have some time. My scanner is not very good, and I take a lot of time to scan stuff. Here there's more cool manuals and stuff. So now let's unpack and take a look at the machine. So here we have the unit, serial 74519. This is a Kaypro II. Pretty cool. The machine is in a very good shape. Very good shape. Very nice. I'm happy. So far, so good. Right? Now, we have the keyboard here. Whoa, look at this keyboard. Man, it's almost brand new. Oh, what is this? Oh, that's not good. There's some kind of, I don't know, oily stuff here. I'm not sure where that came from. I hope not from inside the machine, some capacitor leaking, but it could be. And then we have the keyboard cable here. It attaches here. So it's what, this is an RJ11, I think, or 12, I'm not too sure, but okay, it connects here. Oh, maybe it's from the, oh, it's from this cable. The cable is all oily. Look, oh man, I'm gonna have to clean this up. That's something I'm gonna have to do right away. But here, look, the floppy drives, they have this piece of, or sheet of paper that's for protecting the heads when transporting the machine. Pretty cool. Both of them are here. This one has some oily residue. Now I know that it's from the keyboard cable. Okay. So first thing I'm gonna do, I am gonna clean up this keyboard cable here, because I don't like the way it is, and it's spreading, and it might damage other stuff. We are gonna connect the keyboard. And we need to connect the keyboard to the unit. The keyboard connects here. A reminder, that's my first Kaypro, the first time I see a machine like this in person. What is this reset? Yeah, not too sure. Okay, but we are ready to go, I think. Oh, let's leave the keyboard on the top of it like this. And the screen I need to clean up, but the machine looks amazing, really nice. Now, fingers crossed, let's power it up. And nothing. Okay, I was kind of expecting. This has been in storage for, I don't know, tens of years. Okay, I think I saw a fuse here. Oh yeah, there is a fuse here. Let's take a look at this fuse. Oh, yeah, I don't know if it's gonna be possible to see, but the fuse is blown. And now, I don't know, like that is okay. We know why we didn't see anything on the screen or the machine is not powering up. But should I just replace the fuse and see what happens? Because if the fuse is blown, there is a reason for that, right? Well, okay, I'm gonna take my chances. I'm gonna find another fuse. This is a 1 amp. Yeah, 1 amp, 250 volts fuse. Okay, I found another one, 1 amp. I'm gonna install. It's powered off, yes. Reinstall the fuse, the new fuse. And let's give it another try. And let's go. Oh. Oh. Yeah. Okay. Good news. We have power now. And the CRT is working. Bad news. The drives, and there's a lot of garbage on the screen, and the drives are always on. But this kind of garbage tells me that the character generator, whatever they use on this machine, is working, right? So that tells me that most probably the 5-volt power supply inside it should be good, right? Because this is coming from some logical IC. Maybe this is a RAM issue, right? Because this machine uses a Z80, and if there is an issue with the RAM, then that would prevent the Z80 to work at all, right? It wouldn't work, and then it would not initialize the floppies, and that's why we are gonna see garbage on the screen, right? Okay, so we're gonna have to disassemble the machine, which is always nice because I love to see what is inside these machines anyway. And I think that people watching my videos probably feel the same. Now it's a good time for you to give me a thumbs up and subscribe to NMI. Okay, I switched the camera, and the good news is that a lot of ICs here are on sockets, and I read about that, and that helps maintaining these machines. But the bad news is that all the RAM here, there's 64K of RAM. These are all soldered, those no sockets, so that's not very good. We see the this is the Z80 PO, this is the CPU Z80 SAB 1793, this is the floppy disk controller. There is another PO here and a CO, a serial IO controller here, and these are two parallel controllers. Okay. Oh, there are some more 2114s here, and that one is... this is not... The good news is that we have two EPROMs here. Well, kind of good news, right? I mean, if they were ROMs, they wouldn't lose the data, right? But because they are EPROMs, maybe they already lost their contents or started to lose the contents. So that's not very good. But yeah, it could be a ROM. Maybe I'm gonna starting by reseating these guys. I don't see a video controller IC, so I'm gonna have to check some kind of service manual for this machine. But maybe the Kaypros, just like the Osborne, they don't use any video controller. Probably not, because the display is text only, right? So most probably they are using just discrete logic to generate the video signal. Yeah, but I'm gonna start reseating these four 2114s. So each one, the 2114 is what, 1K by 4 bits. So 1K byte here and another K byte or kilobyte here and another kilobyte here, right? So this is probably the video RAM. Okay, so I'm gonna reseat these guys. I'm gonna power it up without the RAM. It's not gonna work, but I just want to see what the spring looks like. I changed the camera, both cameras, to be honest. Now I think you have a better view. Let's power it on. We should probably, yeah. Oh, yeah, okay. So now we see a pattern, most probably because it reads all zeros, or I don't know, like how the circuit is designed there, or all zeros or all ones, and then that's the pattern that we see. But okay, so there's something on the video RAM. The other thing is the video RAM. Yeah, this is the right orientation. Maybe all the video RAM is good because it is on the CPU to clear the contents of the video RAM when the machine is started, right? So the fact that we see garbage, yeah, just tells me that the Z80 is not doing what it's supposed to do, right? Now, I think, considering the proximity, this should be the character generator ROM. And if we remove this guy, we should see that garbage pattern changing to something probably more constant or nothing at all. Yeah, nothing at all. Okay, so this is the character generator memory. Yeah, okay. So this is the system ROM. This has software. That memory there has only the pattern for characters, right, to show on the screen. But this one has software, opcodes that the Z80 runs. And okay, we should not see anything, and we should still see garbage. Yeah, exactly like that. So yeah, it's at this point we're gonna have to probe the CPU. Maybe I'm just gonna reset the CPU just in case. At this point I'm not gonna try cleaning any contacts. The whole board here looks really clean, but yeah, there could be oxidation, but at this point I'm not gonna try to. Yeah, okay, so we still see the same issue. Yeah, now I'm gonna have to probe the machine, like the Z80. I am very suspicious that it's either this EPROM or one of these RAMs here, but it could be something else, right? We have latches. The 241 here, I don't recall what this is. I recall the 244 and 245. Yeah, these maybe these are buffers, I'm not too sure. But yeah, these guys, I can test them outside the circuit. They're socketed, so that makes it easier to test, right? And probably that's what I'm gonna do next. Worst case scenario, we're gonna have to probe each of these RAMs. I could try, yeah, I could try two different things. There is a technique where you just piggyback a good memory on top of the bad memory, and this way you can diagnose which memory IC is bad. I'm not too sure I like this technique because it only works in some cases, right? But this is definitely something that we can try. I can try replacing the Z80 just to... Oh, the Z80 is very warm. Very warm. I know that these ICs used to work like on this, especially the microprocessors and chips of this era sometimes worked warm, but this one looks especially warm. Maybe it's the Z. I think I have another one. I can try replacing it. At this point, yeah, maybe before doing that, I'm gonna measure the voltage. Oh, the rails are here and we can see the voltage, so I'm gonna check the voltages there. Okay, here we go. We have the ground there, 5 volts, good. Minus 12, plus 12. So the voltages are good. I thought I had more Z80s, but I only have this one. I hope it's working. Okay, so the new Z80 is in place. The floppies are always on, so that's not good. Yeah, the new Z80 is not as hot as the previous one, but it's getting warmer. But it didn't solve any issue, so maybe the CPU is not the problem. And I can remove these this latch here and these other ICs and test them. Yeah, it's easier to just test everything that is on sockets, right? It's easier than removing soldered stuff. Except for this side, these are the disk controllers. Not that they are working, I don't know, but for sure, well, hopefully they don't have anything to do with the garbage we see on the screen, and I don't think they do. So it's probably around this area here: RAM, CPU, ROM, right? Or EPROM. Okay, so first thing I'm gonna do, I'm gonna probe some signals on the Z80. I have the service manual here. We're gonna probe some Kaypro signals now. The service manual states that pin 6 of U63, which is the Z80, is expected to have 2.5 megahertz. 1, 2, 3, 4, 5, 6. Good. A very nice, it's a very good square wave, 2.5 megahertz. So this one is good. We have clock reaching the Z80. The service manual also states that pin 24 of U82 should have a 1 megahertz signal. Where is, oh, U82 is the floppy controller. And it's a 40 pin, so this is 20, 21, 21, 22, 23, 24. And yeah, here we go. 1 megahertz. Good enough. So far, so good. Video signals, they seem to be working. I'm not concerned with the video circuitry. I am more concerned with two things. We need to make sure that the Z80 is fetching the program from the EPROM, and that we are getting data from the RAM. I am honestly more suspicious of the RAM because they usually fail more frequently, right? But who knows? Yeah, first I'm gonna take a look at the RAM. So I'm looking here at the service manual. Oh yeah, and U35 and U38. These are the buffers, bi-directional buffers. U35, oh yeah, 8216. Yeah, these are two 8216. U35 and U38 here. Okay. And the control signal is on pin 15. And oh, okay, so these memories, they have separate pins for data in and data out, and it's pin 14 and pin 2. So that's good. Yeah, there is data in here. Oh, okay, but no data out. 16, 15, 14. Oh, okay. That's interesting. No data. Oh, no data out here. Yeah, this is probably an address line. Yeah, and we can see changing. So the Z80 is trying to read or write. Oh, but there's none of these memories are sending any data out. How is that possible? Because this pin... Long story short, I completely forgot that these DRAMs, the data out is only valid following a CAS assertion. So only after the CAS pin is asserted is that the data out pin turns into an output and outputs valid data. Otherwise, it stays floating or in tri-state. That was the reason I made the assumption that they were shorted, the outputs, and I thought that it was the 8216 shorting the outputs. I ended up removing one just to probe and see what was happening, and after that I saw that the data outs, in fact, they are not a problem. And that's when I noticed that the CAS signal was not being asserted. I also ended up installing a socket on the 8216 so that I can replace it more easily in the future. There is a column address strobe signal CAS on pin 15, and there is RAS on pin 14. Okay, I completely missed that. So let's take a look at pin 14. So the way these DRAMs work, they have an array, right, of columns and rows. So it's like the address pins are multiplexed. So on pin 4, we should have what? RAS. Pin 4. Yeah, we have 1. But we should see a signal changing from 1 to 0. So there's no edge here. And CAS, which is pin 15. Okay, so these signals are the RAS comes from a logic gate, an AND logic gate, pin U39. Yeah, I think we need to probe more stuff on the Z80, especially now something that I completely forgot, the reset pin, right? Let's take a look at all the signals. Reset, if the Z80 is in reset, but I don't think it is, because we see the address lines changing, right? It wouldn't change any address if it was not trying to fetch instructions. So this is 21, I believe. 22, 23, 24, 25, 26. Yeah, it's expected to be in level 1. Yeah, and then so the CPU is not kept in reset. Refresh pin 28. This guy, oh, see, we have a refresh signal coming out of the CPU, which is good. And we have read and write. And there is a 74LS241. Oh, you know what? I'm gonna... Well, let's take a look at the read and write and memory requests. So pin 19. This is pin 19. Memory request. See? The CPU is trying to access the memory. And pin 20 is IO request. Oh, IO request is a little bit odd. But yeah, we're gonna have to take a look at IO later. And to be honest, yeah, IO request is also connected to U62, this guy. Okay, and if that guy is shorted the input, That would explain why IO request is looking this weird, right? And the Z80 is warm. M1 is a, man, I don't know how I still remember these things. I studied Z80 ages ago. M1, from what I recall, is the first machine cycle when it's fetching instruction. This pin basically shows that. So 20, 21, 22, 23, 24, 25, 26. This is reset. 27, M1. See? Yeah, so these are the first machine cycle, or M1. It looks okay. Now I want to see, yeah, memory read we already saw. Memory read, oh no, we didn't see memory read. Memory read is this one. Yeah, makes a lot of sense. We should see it changing more frequently. Well, if there's no real program running, that maybe explains why we see that kind of fixed pattern on memory request, right? So this is 22. Sorry, this is memory read, not memory request. And this is memory write, and we see a kind of also fixed pattern on memory write. Now let me see something. We have the EPROM, and we have a chip select on the EPROM, and there is an output enable. Oh, the diagram is not clear here. I don't know where output enable is coming from, but chip select is coming from pin 15 of U60, which is a 328 decoder, 74LS138, U60 here, and it's pin 15. So, okay, so the only explanation that I can see for this guy being in 1 all the time is that memory request B, pin 4, or one of the other, because this IC has some enables. Oh, I don't want something bad to happen here. Let's take a look at pin 4. Yeah, always 1, and this is active 0. Pin 5. Yeah, so this one has a signal. And pin 6, always 1. This is B bank signal. B because it comes from page B, most probably, right? Yeah. It comes from this system PIO. Oh, okay. Pin 7. That's a problem because I don't have. Maybe we can swap these two PIOs and see what happens. Because the U72, this guy is the system PIO, and this is the parallel PIO, which takes care of the printer here, right? So yeah, okay, so what I'm gonna do, I'm gonna resolder this guy. We just learned that it's not the one that is bad, right? And I am gonna swap these two PIOs and hoping that we're gonna see the bank signal coming out, or we also need to make sure that the PIO is being addressed, right? But anyway, well, I'm gonna resolder this guy because we already know that It has nothing to do with the problem. Maybe the other thing I'm gonna do is to remove these ICs that are on sockets and, you know, test them. Since I already removed the IC, I'm gonna install a socket, right? And as I mentioned, we want to swap these two PIOs. So that's what I'm gonna do now. And now we try again. Okay, here we go. And nothing, same problem, still garbage on the screen. I wanted to see bank pin 7 of the system PIO. 1, 2, 3, 4, 5, 6, 7. Yeah, always 1. Yeah, I don't even know, maybe bank is supposed to be like this because it's running from the EPROM, and that is active in level, yeah, 1. Yeah, so pins 4 and 5, pin 4, this one, okay, so this one has, so this is probably good because it's changing from 0 to 1, so we should see something happening. But this one is always 1, and we should see it alternating. So this is memory request B. Memory request B comes from, oh, it comes from U62. So we're gonna have to test this guy. Okay, I am testing it using my programmer here, and I don't know how reliable these tests are, but according to the test, it is good. It's also good. I'm just gonna try swapping them out. Still garbage. Okay, I'm back. I had a break. Now back to the machine. I'm interested to see why we don't have, I believe it's RAS, right? RAS signal pin 4, is that it? Of the, no, RAS is here. Is it CAS? CAS is 15. Oh no, we have RAS and CAS. Oh, okay, so now we have the, oh, what changed? Memory request is what, 19? Memory request, read and write. Read is 21. IO request 20. Yeah, IO request is odd. Okay, I found a data sheet, and let me see. Read 21, write 22. 21. Read. Oh, this is not good. Oh, okay, it's better now. It's just the probe. Okay, this is 21. Read. And this is write. IO request is really odd. Never goes low. That is not right. Why? Maybe this Z80 is also bad. Oh, you know what? I think I have another Z80 that I can take from a Sinclair. Yeah, let me get the Sinclair. I think I have two Sinclairs and one has a bad ULA, so I'm gonna take that one. Okay, I'm back. I have the Z80 here. I already removed the the Sinclair. I have the Sinclair board here. I already removed the Z80, and this is our guy here. So it's powered off. I'm gonna remove this one. Yeah, that IO request is really odd. I don't know enough about the Kaypro to know if IO request is really used, but I guess it is, because the Z80 has two different address spaces, right? One for data and program, and that is what memory request is used for, and then another just for IO, and it has 8-bit, so 256 addresses there. So I'm guessing that in that IO space, we probably have peripherals mapped, maybe even the video, I'm not too sure. So now I installed the new, or another Z80, and let's see, I'm gonna power it on. Let's see if we have a better. Oh, huh. It's working. Let me see. Oh, but IO request is still odd. Huh. I don't know why. But now we have the screen working. Let me show you. Okay, now you should probably be able to see the screen, and it seems to be working. Amazing. It was just the CPU. Yeah, and the spare Z80 that I had here is also bad. Good to know. Now I'm gonna reconnect the floppy. Let's see. Reconnect the floppy drive. And oh, nice. It's trying to, oh, again, you can't see. Okay, I moved the camera. You should be able to see the LED here, right? And if I turn the machine on, it's trying to load the operating system from drive A. Now all I have to do is to get a boot disk that I can use here. And for that, I'm going to use my 386 that is behind me there, and that I already showed here in this channel. So I'm gonna use that, and I'm gonna try to find images on the internet. Okay, I'm back. I managed to write. Can you see here? Yeah, I managed to write a disk image, and let's try it out. I'm gonna link the place, the website that I found these images. I'm gonna link in the video description, and I also gonna link the utilities. Maybe I'm gonna show a quick image of the program running and the specs that I used. In this case, I used a 360K floppy drive running on DOS, and single-sided and single step. Let's see, the disk is in place. Let's power it on. Oh, I see the, yeah, it works. Amazing. Oh, I'm happy. Yeah, the machine is working now. Kaypro II 64K CPM version 2.2. Oh, there's some artifacts sometimes, like the screen. Maybe there is a capacitor on the analog board. Yeah, but it's gone now. Let me see. I decided to remove the power supply because that shaking or the noise sometimes showing up on the screen was annoying, and that is clearly not right. So I decided to start with the power supply, and here it is. The first thing that I noticed is that it's a good thing that I removed it, because look what I found here. This is a RIFA capacitor. So this is just waiting to turn into smoke. I believe these three caps here are also RIFAs, so I have to replace them all, or at least remove them, right? Because their main function here was to prevent EMI. Why don't you share this video with your friends? Now I'm gonna demonstrate some quick features of the Kaypro and CPM. I don't have all the applications, like the disk images for the applications that shipped with the Kaypro, but I showed you all the manuals. It shipped with WordStar, some spreadsheet applications. It was a pretty cool software package. But here we're only gonna see the basic CPM. If we press reset, the system is gonna boot up, right? And if we do it there, we can see the files. I have another disk on drive B, and we can do format the diskette in drive B. So let's do F. Insert the diskette to format in drive B. Yeah, it is already there. And it's formatting now, just like what you or we are used to on MS-DOS. In fact, a lot of MS-DOS was based on CPM.
right? Even though it's verifying the disk now, even though the system here is much simpler in terms of it's only text and all this kind of stuff, but still the foundation is what we see here. Yeah, the disk is formatted. Now I am still on drive A. If we do a dir on drive B, we're gonna see no files there. Now let me show you. There's another utility, pip, for copying files. I know it's odd, but that's what they call the utility for copying files. So we have a bunch of, for instance, I'm gonna copy stat because I want to show you stat. So we can do pip b stat.com equal a stat.com. Now CPM is gonna copy the file from drive A to drive B, and if we do a dir B, we are gonna see stat.com there. Now we can go to drive B and run stat here, and it shows that on drive A we have 3K free, and on drive B 185K free. The system has other utilities, as we can see. For instance, we have move CPM and sysgen. Sysgen is nice because we can make any disk bootable, right? So I can do sysgen B here, source drive A, destination B, now if we press enter, it will reboot. I'm just gonna swap the disks here, and you will see that the machine is gonna boot now from drive A, and if we do dir, we only have one file, right? Go back. I'm gonna swap them back here. Other stuff that we see, I already showed pip, submit, and xsub. I'm not too sure. I think these are for like running kind of scripts equivalent. Add is a simple editor. ASM is an assembler, so it can translate and generate as an executable code. DDT, it's fun. DDT reminds of the insecticide, right? And this is the debugger, so it's called DDT just as a homage, I don't know, to the fact that this is a bug killer, right? Stat we already saw. sBasic is a basic compiler. I still need to make it work. I don't know why I didn't manage it to work. Config is a configuration utility. So here, this is a Kaypro specific application. You can configure some options, cursor key definitions, the baud rate for the serial port, and this kind of stuff. I am not gonna do any of that right now. Yeah, but in terms of CPM, that's it. Well, it's also in terms of this video, right? I think this is already a very long video, but I hope you liked it. I am super happy with my Kaypro. I think it's a fantastic machine, very good looking, and a very nice example of a CPM machine, just like my Osborne. So if you like this video, please give me a thumbs up, and don't forget to subscribe to NMI and add a comment to the video, and see you next time. Bye.